Okay, hello and welcome to my channel. Today we're gonna continue to talk about the step potential, and today we will take a look at the wave packet with energy less than 0. So I left this here so I won't have to write that again. Now we're gonna jump straight into writing our wave function, the incoming wave function. After Fourier transform, EIKX, and the time evolution. Next is our reflected. Okay, is minus IKX e to 2I delta and e to the minus IET over each bar. And next is our transmitted wave, which doesn't exist. So this guy doesn't exist. So we only have to deal with the part where x is less than 0 this time. So both of these are in the region x less than 0. So we're gonna jump straight into our stationary phase approximation. So let's start from here. Approximation. Right, and we would need the phase to be stationary. This would go as x minus e. We take e as h bar squared k squared over 2m, and that would give us h bar k, which we calculate is k naught over m. Therefore, your x is equal to h bar k naught over m. Next one is our approximation for the reflected wave. Minus kx plus 2 delta minus et over h bar. Square that equal to 0. Right? So you'll see here it looks a bit weird, but actually this part is just gonna be a Wigner time delay, which is very trivial. It is important, but it won't affect your wave in the amplitude that much. This one is minus plus 2h bar, the derivative of your delta. All right, so wait, no, h bar, I would have to have a t. All right, you have to fact that is h bar have to be acting on this guy as well. Now the minus h bar k naught has to be acting on this guy as well. Right. Yeah, I think that looks correct. Actually, don't remember. Let me just look at the solution real quick. It's actually x is equal to h bar times t minus 2h bar delta of e. That is your answer for the x. So that is all you have to know on the x less than 0 region. Next is your x greater than 0 region, and as we solved it before, it is just a decay, and this time your wave function is gonna decay to the point around 1 over kappa. And with kappa is equal to V0 minus E. Okay, so that part is not really that important. Okay. But when you take this and you calculate the total energy of the system, what you get back would still be greater or equal to V0, as the energy would just be your energy plus the uncertainty of the energy, which you just calculate the uncertainty in P for you to get the kinetic energy. And I think that would be something like E total would equal to E plus the delta in E, which is E plus V0 minus E, and this has to be greater or equal to V0, so it doesn't really violate anything. All right, so yeah, that's it for today. Goodbye.